Okay, welcome to part 3 of this video lecture series on chapter 4 for the server virtualization course. We're going to start talking about various features and performance considerations with Hyper-V, not with Hyper-V, with VMware vSphere, its family of products, the various components. We'll talk a little bit about the history and the way things have changed since vSphere 5. We're studying vSphere 6. I believe it is 6.5. The latest current version is 6.7, so there may be some subtle differences by the time you get out into the workforce dealing with this. Or if you get into the classroom and deal with one of our ESXi hosts. One of the other things we're going to do as we go a little farther along is compare what you can get with the free vSphere hypervisor with vSphere ESXi with the licensed vCenter server, and then compare all of that to Hyper-V once we start talking about Hyper-V. So there are three primary components of your vSphere architecture. Your vSphere ESXi hypervisor, also referred to as a vSphere host or an ESXi host. ESXi stands for Elastic SkyX. Then there's your vSphere client, which is a piece of software which you can install essentially at the desktop, and it will reach out to an ESXi host, and you can manage that. That is compatible with the free version of ESXi host. The free version of ESXi host is not as feature complete as the licensed version. You can manage a single ESXi host with vSphere with a vSphere client. You can manage an entire ESXi data center with a vCenter server. With vSphere 5, VMware designed the hypervisor to give you improved performance. They took a GUI console out of the process and renamed the whole thing ESXi. So when we talk about an ESXi host, we mean a physical computer running a bare metal hypervisor. If you were to go into the classroom, into room 220, those 10 PowerEdge servers have ESXi running on them. And there is a console, a graphical console, but all you can really do is interact with it using a keyboard and mouse. It is about a half step between a command line and a GUI. Now, one of the reasons we might do this, or for the same reason you might deploy a server core instance, or a server core instance of Windows Server 2012, 2016, or 2019, or a headless Linux server with no GUI. This improves performance, it improves reliability, it improves your attack surface, because your GUI adds layers of abstraction between the user and the OS. Now, the core of that hypervisor is the VM kernel. Technically speaking, it's a flavor of Linux. And we'll see that term again in a little bit, that when we talk about a VM kernel NIC inside a VM, that's tying into the ESXi host. And that kernel controls all the VM access to the ESXi host's physical hardware. So we've got a table here, so we can compare. There are a lot of things that are similar in terms of the host. You have the same number of potential logical processors, the same amount of physical memory, literally 6 terabytes, potentially 4,000 virtual CPUs. They both support SLAT, they both support ballooning, they both support transparent page sharing, they both support memory compression. We'll talk about each of these in turn. When we start seeing the divergence is here. In terms of your vCPU, your VMs and your virtual CPUs, your free version of this supports fewer virtual CPUs. It does not support hot add, as in with the free version of ESXi and the vSphere client, you can't add more memory to your virtual memory to your virtual machine on the fly. The free version of this does not support clustering, does not support vCenter Server, does not support load balancing, does not support high availability. You need vCenter Server to manage that load balancing, to manage high availability, DRS, vMotion, storage vMotion, the lot of it. So for a true data center solution, you're going to want, if you're going the VMware route at all, you're going to want the licensed ESXi host. The license will open up all the features. It's essentially the same kernel, but not all the features will be unlocked with a vCenter server. So you can manage all of that. Now, one of the things it gives us, one of the bits of alphabet soup here, NUMA. NUMA is non-uniform memory access. That allows, particularly in a multi-processing environment, that allows the OS to be a good deal more strategic and specific in how it accesses memory. The CPU can use its own local memory rather than shared memory if necessary. This also allows transparent page sharing. Transparent page sharing is particularly useful because if you have multiple instances of the same operating system running in multiple virtual machines, they all have some of the same executables running, the same drivers, etc. So rather than having 50 instances of the NTOS kernel or NTFS.sys or the hardware the HAL DLLs or whatnot, or 50 different versions of the same Linux kernel running, that's really a massive waste. So using transparent page sharing, all these VMs can reach into the same memory in the physical machine as long as they have enough in common. That will allow us to reduce the amount of paging that we need to do back and forth between physical memory and physical storage for virtual paging and that kind of thing. It's like memory compression, actually. If you find that you've got memory pages that aren't being compressed, to reduce the amount of time we spend swapping those to and from disk, we compress them and then swap them to disk. And then when we need them, we pull them out and decompress them. We also have hot add support, so that a vSphere, an ESXi host supported by vSphere, can change the amount of virtual CPUs, can change the amount of virtual memory while the guest is running. Think about the way that you can't do that with VMware Workstation. You can't physically do that. Add certain kinds of hardware, or add memory, or change the size of the hard drive while the machine is running. In a truly converged environment, we have a lot of those rules go away because we truly understand everything is virtual. I'll talk next about Hyper-V and its performance and features. Thanks, and we'll be right back.